There's a lot of vocabulary involved in this chapter. May even just have a vocabulary test because there's so much to it. But this is the rectangular coordinate system, or the Cartesian coordinate system. And all it is made up of is an x-axis, which is labeled here, and a y-axis, which is vertical here. And they cross, it's really just two number lines that cross at their 0 points. And you name every point in this coordinate system by an ordered pair. Just like this. The ordered pair has an x and then a y. Now these words down here, I hope you know them. I kind of doubt you do. So let me point them out. The x coordinate is called the abscissa. A-B-S-C-I-S-S-A. Abscissa. It's a weird sounding word. And the y coordinate of any ordered pair is called the ordinate. O-R-D-I-N-A-T-E. The ordinate. Now, if I took any random point and placed it on the coordinate plane, there are 6 places that point could be. It could be in quadrant 1, quadrant 2, quadrant 3, quadrant 4. That's 4 of them. It could be on the x-axis, which is not in a quadrant. It could be on the y-axis, which is not in a quadrant. So it can be 6 places. Quadrant 1, 2, 3, 4, x-axis, y-axis. What is the only point that can be in 2 of those 6 places at one time? 0, 0. And what do you call 0, 0? The origin. The origin is actually on both axes. It's their intersection point. So 0, 0 is called the origin, and it's actually on the x-axis and on the y-axis. Now, I know you may have noticed, and I guess you guys have probably seen before, that the coordinate plane, the quadrants are kind of backwards. They start here at 1. And in quadrant 1, everything is positive. X is positive and y is positive, and that's why I wrote this plus plus here in this ordered pair, because both x and y are positive in the first quadrant. In quadrant 2, which is here, x is negative and y is positive. How do I know that? Well, if I start at the origin and I go to the left, I get negative numbers on the x-axis, but go up to get up in the second quadrant. If I go up, the y's are positive. So that's why x is negative and y is positive. Down here in quadrant 3, both x and y are negative. Because if I go left and down, those are both negative directions, left and down. Quadrant 4, x is positive, I go to the right, but y is negative, so it's plus negative in quadrant 4. So every point that can be named can be in 6 places. The x coordinate is called the abscissa. The y is called the ordinate. Is that easy stuff right there? Does anybody have a question? Abscissa. A-B-S-C-I-S-S-A. We still copying a few things? Okay. All right. On your graph paper, I need for you to graph these points. Now notice the points are labeled A, B, C, D, all the way to N. So when you graph the point 2, 0, I want you to put an A beside it. And then when you graph the point 2, 3, I want you to put a B beside it. And with your ruler, real or redneck ruler, whichever one you're using, draw a straight line between A and B. And then you'll graph C and draw a line to there. And you're going to continue drawing lines as you go to points, and you're going to make a picture of something that you will recognize. Now remember, when you graph points, you do X first. You go across, either left or right, and then you go up or down. All right, I want to see how you draw your graph on your graph paper first. So I'm going to come around and look and see how this is going as we go. This is negative 1/2. Yes, it is. Negative 1/2. Now, also, I want you to notice that A and N are the same point. You know why that is? Because this is going to make a complete picture, and you're going to stop back where you started so that the picture will be complete. Make sense? Kind of weird, isn't it? All right.
So we need a pretty big graph.
Well, let's look how big it needs to be. What's the biggest X value you see? What, -3 and then +2? So it doesn't have to be very wide, -3 to +2. And how far up does it need to go? +3? How far down does it need to go? -3? So that's not very big at all. I'm going to pause this and come around and see how you guys are doing. Overall, you guys did pretty good. Same mistakes every time I do this lesson, though. When you are numbering your coordinate plane on the blue line on the graph paper, you don't skip around. It's just one right after the other. The x-axis and the y-axis go on the blue line, and then the numbers go on the blue line, not in the middle of the boxes, and you can't skip 2 here and 3 there. You know, it's got to be one right after the other, numbered consistently, consecutively on the blue line. All right, so our graph should look like this.
Yep.
All right, so this is A, the point A at 2, 0, and B is up here at 2, 3, and C, I'm sorry, yeah, 2, 3, and then C is at 1, 0, and this point right here is one that eludes everybody. They're like, where do I find -1/2, -1? Well, if this is -1, then this is -1/2, and then down 1. So this is D. Yeah. All right, so then this is D, and then E was -2, 3, I guess. And then here's F. And then the point G is at -3, -3. And here's H. And then I, J.
Okay.
I was trying to think, did I skip something? And it came right back. Now, normally you would not have 2 points. That's kind of misleading to have 2 points naming the same point here. But wherever you're, like you were saying, wherever the M is a little lopsided, then that's the point that's wrong. And it's real obvious. Like you can just see, oh, right here is where I missed it. That means that particular point is graphed incorrectly.
You tell me exactly.
So, no, I didn't. No. Nothing like that would be my fault. All right, so now I need you to draw another coordinate plane and graph these points.
Maybe this one will be.
Now this one's got a little decimal in it too. It's got half here, and it's got -5.5 here. All right, now if you'll notice, look at my letters: A, B, C, D, E, F, G, H, I, J, K, L, M, N, P. I didn't do an O. You know why? Because I didn't want you to think origin. It's not, the origin's not part of it. Okay? All right, so graph these points. And listen, this time, listen carefully. Number the x-axis and the y-axis correctly, and then label the points A, B, C, D, E, F, G as you go, and use your ruler, connect. Now you'll get another totally different picture this time. It is not even a letter. It's not even a letter at all. All right, so graph these points. I'm going to pause the video just a second. All right, so here's where all the points are supposed to be. And we're supposed to get an airplane. All right, so let's talk about a little vocabulary, and then we're going to go back and answer some questions about our M and our airplane. First of all, and remember I told you we're going to probably have this little test on just vocabulary. But a relation is a set of ordered pairs. And we need to know that. A relation is a set of ordered pairs. Let's write this down, guys. There are 5 ways to represent a relation: a set, table, mapping, graph, or equation. We're going to talk about each of those, okay? So a relation is a set of ordered pairs. So we have just graphed 2 relations. The M was a set of ordered pairs, and the airplane was a set of ordered pairs, and they both qualify for relations. Now, we've seen that represented as a set of ordered pairs. I typed them on the board. And then you represented it as a graph.
I got your back.
All right, a relation is a set of ordered pairs. If I have a set, sorry, this is kind of messy. If I have a set, it just looks like that. If I have a table, sometimes you'll hear it called a T table because it looks like a big old T, but you have your X here and your Y there, your X here and your Y there, just the same points out of the set, and that's what a table looks like. Now a mapping, usually it's like 2 bubbles or 2 oval shapes or maybe even 2 rectangles, and you write all your X's here in order from least to greatest, and you write all your Y's here in order from least to greatest, and then you just match them up, you know, like, make sure that's going the right way. Alright, -1's paired to -2, 0's paired to 0, 1's paired to 2, 2's paired to 4. I made it real simple. And 3's paired to 6. So that's what a mapping looks like. An equation, we're going to be looking at lots of different equations. This would match up with those points up there. And then graphs, you know what graph looks like. We just did 2. So set, table, mapping, graph, equation. So if I say, what is a relation? You say it's a set of ordered pairs. If I say list 5 ways to represent a relation: set, table, mapping, graph, equation. So already you need to know those. Alright, also we've talked today about an abscissa and an ordinate, so let's use those. Let's write down the definition of domain and range. Alright, a domain is a set also. If I have a relation, and I have a table, a mapping, a graph, a set, whatever I have, and I pull all the X's from all those different ordered pairs out, then I have the domain. The domain is the set of the abscissas or the X's of a relation. Again, what is a relation? What did you just write down? A relation is a set of ordered pairs. So if you have a set of ordered pairs, whether it's represented as a set, table, mapping, graph, or equation, if I have a relation and I take all the X's out, I have a domain. A range is the set of ordinates or Y's of a relation. So if I have a set of ordered pairs and I pull out all the Y's, then I have a range. Now, it's going to be required of you to know, to be able to find the domain and the range, no matter if I have an equation or a table or a set or a graph even. So I'm going to go back and look at the 2 graphs we've already made today, and we're going to write down the domain and the range from each of those, okay? So let's go back, and let's just look right here. I'm going to cover up this second one so we don't get confused. But just out of this set of ordered pairs. And if I'm going to go from least to greatest, and I'm looking at the domain, what's the only thing I'm looking at in each of these ordered pairs? I'm just looking, for the domain, I'm just looking at the X. So I'm just looking at the X. Alright, so from those X's, if I'm listing them in order from least to greatest, what's the first X you see? Negative 3 and then negative 2. Is there a negative 1?
No. Negative 0.5.
Negative 0.5, good.
Negative 0.5.
Sorry about that. Is there a 0? Alright, is there a 1? Yes. Now you see how even though there's more than one of those, I'm just listing it one time. I hope you're writing these down. Is there a 2? Yes. Is there anything bigger than a 2? No. Okay. So now looking at the range, am I going to look at the X's or the Y's? We're going to look at the Y's. So let's see if I can just pull all those over. Just want to look at the Y's. Alright, so to find the range, what is the smallest Y value that you see?
Negative 3.
Negative 3. Alright, and then what comes next? Is there any other negative numbers? Negative 1. And then we have what, 0? Alright, what about the positives? Is that it? Yes. So I have domain and range. Now from a set, a table, or a mapping, if you'll think about it, if I'm looking at a table, where would I find the domain? Right down through there. Whoops. Right down through there. Right? Where would I find the range? Right down through there. That'd be easy, wouldn't it? Look at a mapping. Where would I find the domain? Right there. Where would I find the range? Right there. So those would be real easy. All right, now I want to go back and look at the graph here and find the domain and the range. Should it be the same as I got earlier from that same set of points? It should. All right, let me teach you how to find domain from a graph. You just go from left to right. From left to right to find the domain. Y'all with me? I would write that down. Okay? All right, from left to right. Now, I'm not going to go A, B, C, D on my points. I'm going from left to right. So if I start furthest to the left, all these points are what on the X? Negative 3. And then coming over this way a little bit, what are all these? They're negative 2. Moving over a little bit, what are these? Negative 0.5. And then going over a little bit more, what's next? What are these? 1s? And then what are these? 2s. Is that the same domain we got a minute ago? I hope so. All right, to find the range, you go from bottom to top. I'm talking about to find the domain and range on a graph. It's different, because if I have a set or a table or a mapping, I can just look at them, can I? It's easier, really. Graphs are kind of tough. All right, so if I'm going from the bottom, again, I'm not going to do A, B, C, D. I'm going to go from the bottom up. Okay? So starting at the bottom, what is the first Y that we see down here? Where are all these? they're down at -3. All right, and then the next point I see is this one, and it's at, on the y, it's at -1. And then the next points I see are up here on the, it's 0, isn't it? And then the next points I see are up at 3. Is that tough? Left to right for domain, bottom to top for the range. All right. I want you to go back to here. And with this set, I'm going to give you a minute to find the domain and the range. All right, I'll do the highlighting for you because I know it's kind of hard. All right, you go through and list the domain in order least to greatest. And if they're used more than once, you only list them once. Find the domain. Oh, thank you. Oh, wow. Okay, how about that? Is that better? Okay, find the domain. List it least to greatest and only list them one time. That's right. I'm going to pause the video and give you a minute. Okay, with the Y's highlighted, find the range. Okay, if I'm looking at the domain, what is the smallest x that you see? -6. And then? Good. And then -5. -4. Is there a -3? But -2, right here, right? All right, is there a -1? Yes. Was there a 0? All right, what about positives? 2, 5, and...
No.
Is that it?
Yeah.
Kind of ran out of room there, didn't I? All right, on the range, what's the smallest range? And then, -2. Does everybody agree? Okay, now let's see if we can do it looking at the airplane. From the domain, we're going to go left to right. Do it. Just looking at your graph. Don't cheat and look at that list you just made. Do it from your airplane. Just do it from the points you made.
Without the numbers.
Well, I told you to number your x's.
Oh, I did.
Okay. Did I skip some points right here?
Yeah, J and K.
J and K are up here? Okay, so I need to fix some of these. So did I go further than S? It did, didn't it? So JK, and this is L, M, N, P, Q, R, S, T, and U. So it ended at U. Okay. So if we're going to go from left to right, how far over did these go? Where am I? At -6. And then these two are at -5.5, aren't they? And then these are at -5. Y'all see what I'm talking about going left to right? And then what comes next? After these come, bless you, come these. And after that, I come, what, up here? Up and down here, -2. And then -1. Now, how many zeros? Come all the way over here to 2. And then 5, and then 9. We read a graph like we read a book from left to right, okay? Okay, going from bottom to top. Now remember, I'm not doing A, B, C, D. I'm going bottom to top. So if I start down here, I'm at -4. And then up to here at -2. And from there, it looks like I had, what, some zeros? All these are zeros. And then I go up to, what, 1? And then up to 3, and then all the way to 5. Is that the same numbers we got when we did it the other day? Other way, I'm sorry? Yes, it is. I got one person telling me yes. So what's harder, from a set or from a graph? To me, I mean, that's your opinion, but to me, it's hard from a graph, so you have to just look left to right for domain, bottom to top for the range. All right, what is a relation? Set of ordered pairs. What are the 5 ways to represent a relation? Yes. What is a domain? X's or abscissas of a relation. What is a range? Set of Y's or ordinates of a relation. All right. We're going to write down the definition of a function, and tomorrow you're going to stand up beside your desk and say it for me for a grade. All right, so you're gonna stand up without looking at. You're gonna know the definition of a function, and you're gonna stand and say a function is a special type of relation in which each element of the domain is paired with exactly one element of the range. Now, 5th block is gonna say it to me Monday. You guys are gonna say it to me tomorrow. Okay? A function is a special type of relation. So stop right there. What does this word mean? It's a set of ordered pairs, right? In which each, underline that word each. It's not the word one. It's the word each. If I said I was going to give each of you something, what does that mean? I'm just going to give one of you something? Individually, one at a time, okay? And so each element of the domain, what's the domain? The set of X's. Is paired with exactly one. What does that mean? Could there be 2? No, exactly one element of the range. What's the range? The set of Y's. All right, let you copy that down, paying careful attention, because you want to get it right. You want to get a good grade. It's be the easiest 10 points ever. A function is a special type of relation in which each element of the domain is paired with exactly one element of the range. Guess what number 1 on the test is going to be? Define function. All right? So I really, really want you to know what the definition of that is. You're going to stand tomorrow. 5th block is going to do it Monday. You're going to stand up and tell me the definition of a function. I'd like to do it on a volunteer basis, like I don't even have to call you on you. You just stand. Y'all ever been to a testimony service where you just stand when you get ready?
Yeah.
I want you to stand up when you get ready, and we'll go one at a time and just say the definition. If it gets down to I have to call on you, I will.
Are you not gonna be here for?
Yes, I am.
So we're gonna hear each one of us say it, right?
Again, yes. Yeah,
And then we're
28
gonna
times.
say
So.
it. Like we're gonna hear our friends say it, right? So then we don't even have to like learn it, baby. If
So
they
who's
learn
going to
it-
go first?
Destiny.
Yeah, we're going to volunteer her. That's exactly right.
I volunteer.
You can look this time and we're going to say the definition of a function together.
I don't do it.
Good. All right, you can look if you want to, and we're going to say the definition of a function together. That means in unison, like a choir. Not everybody at different times, okay? Together, understandably. We're going to say this. Ready? A function is a special type of relation in which each element of the domain is paired with exactly one element of the range.
I thought
Perfect.
we was closing our eyes, so I was getting ready to close my eyes.
Well, I told you you could look. All right, this time, close your eyes and you can't look.
Oh, you gotta say the whole thing.
All right, we're gonna.
Whole code when we're talking.
All right, when you get lost, don't go. Just stop.
Just move your mouth and act like you know it.
No, don't even do that. When you're lost, stop. But the rest, if you know it, hang with me. Close your eyes.
Wait. Can we not just say a special type of relation? I don't want
Close your eyes.
I forgot it.
I'm ready.
All right, close your eyes. I'm waiting on James to close his eyes and Tanner. All right, everybody close their eyes. A function is a special type of relation in which each element of the domain is paired with exactly one element of the range. Y'all did that, la 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 la.
I quit. I stopped when I did.
All right, so listen. Most of you hung with me through half of it, so you're halfway there.
One
I
element.
got to the main.
Listen, if you'll notice, I underlined the hard words. Each, domain, exactly one, and range. That's where we always get stuck. And so I underlined the hard words for you.
No, like I said,
And so you guys can study that. Yeah, element sometimes gives people up, okay? A function is a special type of relation in which each element of the domain is paired with exactly one element of the range. That will be no problem for you tomorrow. All right. Our vertical line test. Let's talk about that. First of all, which way is vertical? Yes, up and down, up and down. The horizon goes left to right, okay? So that's horizontal. So vertical is up and down. If you stand up, you're vertical. A vertical line test is used this way. If any vertical line can be drawn on a graph and it touches more than one point of the relation, the graph is not a function. All right, so let's see if we can find some
I was
graphs.
writing that down.
You can. All right, let's look at this. Does anybody know what you call this particular graph? It's nonlinear, that's true. Now it starts with a P. Whoops.
Parallel. Parallel.
This is a parabola. It's spelled parabola. It's a parabola. It's a U shape, okay? It's a U shape. All right. Now let's use the vertical line test on. Now here's the thing about the parabola. As it goes up, it doesn't ever go straight. It continues to widen out. Like as it goes up, it also goes out. Y'all with me? All right, so is this a function? Does it pass the vertical line test? Is there any vertical line that I could draw and hit more than one point on this parabola? No. Okay? And so I would say, I would draw a little sketch for a parabola. Don't make it perfect. Just draw it on your notes. Draw your little X and Y axis. Draw your parabola. And let's call this a function. This is a function. And what's a function? The vertical lines? Yeah, to show you use the vertical line test. What is a function, Dakota?
I'll have it.
Function is a special.
Oh.
Yes, ma'am.
It's a special, wow, that was good. A special type of relation in which each domain,
Each element
each element of the domain is paired
with exactly.
exactly one element of the domain.
Good. And this graph passes the vertical line test because I only hit 1 point each time. All right, draw this V-shaped graph. We're going to learn that this is called the absolute Yes, good. This is
I've heard that
absolute
one.
value graph.
That's what
All right, now, it like the parabola, it never just goes straight up. As it goes up, as it goes left and right, it also goes up, you know. So, does this pass the vertical line test? It does. You know, everywhere. And so this is actually called the absolute value function. I almost said that word and gave it away. But this is called the absolute value function. And how, I'm glad you said what you, absolute value, yeah. Notice that it's shaped like a V. The graph is shaped like a V. So that's a good way to remember it's absolute value. So draw your little sketch of a V shape. Do you some vertical lines, say that's a function. Passes the vertical line test. All right, this is what kind of a line? That's right, this is a horizontal line. Ah, guys. This is a Z. Does it pass the test? What? How many points am I hitting on the line? One at a time. With each vertical. Is there any way I could draw a vertical line and one vertical line and hit 2 points? No. So this is called actually the constant function is what a horizontal line's called. All right, let me ask you a hard question. This is one of those questions where you have to use your brain a little bit and think. What is the only kind of line? Positive slope, negative slope, zero slope like this, vertical line has no slope. What is the only kind of line that's not a function and doesn't pass the vertical line test?
Parallel.
Positive, let's see. Positive slope, negative slope, zero slope like this, horizontal, vertical. What wouldn't pass the vertical line test? Yeah, a vertical line. Because if I drew a vertical line on top of a vertical line, would I hit 1 point or would I hit infinitely many points, right?
Does parallel lines have anything to do with what
That's
they do?
crazy.
Not yet, no.
It's a vertical line.
All right,
test.
now this,
What?
listen. Yeah, right, exactly. So it's a vertical line right up on top of a vertical line. It's going to hit more than 1 point. It's going to hit all of them. All right, so this line's got a positive slope. It's increasing from left to right. Is it a function? Yes. Draw your little quick sketch of a line that's got a positive slope. Draw your vertical line. Say that thing's a function. Okay, now let's look at one that's got, what do I not have anymore? Let's see. I need some. I'll go back. All right, let's look at that vertical line. Is that a function?
No, it's not a function.
It's not a Wait.
Not a function. All right, what about if I had a circle?
Yes.
You're right. If I had, let me see if I can get one up here real quick. If I had that's just not a circle. If I had a circle, I think that's an oval. But regardless, if I have a circle and I draw a vertical line, I'll just use the one that's on here. How many points did I hit? 2. That's not a function. Now, is it still a relation?
Yes.
Yes.
But it's not a function.
It's still a shadow.
So today we said a relation is a set of ordered pairs. There's 5 ways to represent a relation, and they are set, table, mapping, graph, equation. The domain is the set of x's, and the range is the set of y's. And we know what a function is, and we also, listen, I'll go back to this. For you guys who are still copying this down right here, the vertical line test is used to determine if a graph is a function. All right, we're going to stop right there, and you guys are going to tell me definition of a function tomorrow.